Welcome to this episode on command pattern in Ruby. I'll be discussing about how you can use command pattern using Ruby. This is the second of the series of episodes on design pattern. This material is based on the Neil Ford's presentation during RailsConf. So examples have been stolen from his slides. So before I get started, I want to go over a few basics, which I think was not really covered by Neil Ford's slides. I was not in his presentation, so I don't know if he went over this or not. So let's get started. I want to briefly go over closure, uses of closures, and discuss about scope versus extent, because there is a lot of confusion between scope and extent, and people are not even able to label the term extent, and they tend to confuse scope with extent and extent with scope. So let's try to clarify that. So what is a closure? A closure basically has two main things going for it. Number one is the ability to access variables outside the block. If you had watched my previous screencast on blocks, I show how to use proc objects, lambda, and all those things that you can do with it, and how they are able to access variables which is defined outside of the block. Okay, and the number two thing about blocks is the value established in one invocation remains available in the next invocation. So the variable has indefinite lifetime. Okay, I will go over an example to illustrate this concept. I'll come back to this thing later and you'll see this thing in action. So what do I mean by this indefinite lifetime? Before I go into the indefinite lifetime, I'll come back to that topic later, but let's keep continuing with the series of concepts we need to cover. Okay, closure. Then the next in the thing is describing, what are the uses of closures? Why do we really need these closures? Okay, uses of closures. There are three main uses. Number one is the frameworks. Frameworks can allow users to customize behavior by passing closures as arguments to functions. If you have seen my previous screencast on higher order procedures in Ruby, in one of the older episodes I go over this higher order procedure and show you how I separate out the list processing logic from the predicate logic, which determines what element needs to go into the data structure container. So that is basically a way to customize the behavior of a function by passing uh, closures as arguments to functions. Whenever you're passing arguments to functions or returning, whenever you're passing closures as arguments or returning closures as a result from a function, it's called as IRDA procedure. And I have covered this in detail in that episode. And number two is delayed execution. There's lots of practical example of this. One is you might actually define the proc objects before the Rails app loads. You could somewhere in the environment.rb or somewhere you could define a proc object, and during runtime, based on certain things that happens, for instance, RSS feed or something is uh, happening in real time, event based system, it's you're downloading something and you want to transform this based on the proc object, project proc object, which encapsulates the logic of what needs to happen to the RSS feed. Whether you're parsing the entire thing and you're creating some kind of a mashup or anything you could do, during that time you actually execute the proc object by calling its call method. So the delayed execution is one big advantage. The number three in the item is kind of very, very subtle. And I think one of the blog posts by James Buck kind of went through this thing where multiple functions can be produced which close over the same environment, enabling them to communicate privately by altering that environment. So it does sound like how Capistrano kind of uh, implements the some of the things inside using its own DSL. So another thing about the shared context is like you may um, have some questions after watching the hired out procedure. Like for instance, why do we need to keep passing these functions, from one function to the other and return them as a result and so on? Why can't we just use a procedural language which calls another function? The answer to the question lies in this shared context, where the closure basically has access to the data which is enclosed in the outer method, and when it modifies that variable, it's actually it changes. So it's kind of like there is an effect. Whatever operations that happens within the block tends to affect the value of the variables that is accessing in the outer method. Uh, so that's kind of like a very subtle thing which people tend to overlook. And if you look at the closure definition at Wikipedia, it goes over these things in detail, so you can read up on it. And next, we saw the use of closure. What's next? Okay, we saw closure. We saw what uses of closures are. Now I want to go over this scope versus extent. What do we mean by scope and what do we mean by extent? A scope is nothing but the scope of a variable describes where in a program's text the variable may be used, whereas the extent describes when in a program's execution a variable has a value. Extent has to do with the lifetime. You remember the second point in closure, I said the value established in one invocation remains available in the next invocation when you have a closure. And I said the variable has indefinite lifetime. You can also say the variable has indefinite extent. So it's kind of like it's easier to think of lifetime, so you can just think of extent as basically a lifetime. So lifetime and scope are entirely different though. So you shouldn't think they are the same. The scope of a variable describes where in a program's text the variable may be used. If it goes, when it is being used and it's available, it's called as a bound variable, right? And if it goes, something goes out of scope, it's basically unbound variable. It's not available anymore, and in Ruby it will be nil, set to nil. And maybe it's not even that variable is not even visible basically. Okay, whereas extent has to do with its value and its lifetime. So it's kind of visibility versus lifetime. You can think of it that way. So it's very useful concept to know, and it'll allow you to understand a lot of concepts in Ruby. So we have seen what closure is, what uses of closures are, why we need them, why can't we just use functional, why do we need this functional programming concepts like closures, why can't we just use procedural programming. uses of closures gives you three distinct advantages, as we saw, and scope versus extent. Now let's come to the commands or pattern in Ruby. I'll just briefly go over this, how the commands are kind of related to closures. Closures allow us to implement command pattern in a very elegant way, and we will see some examples once we get this thing out of the way. Commands are nothing but closures, and whenever you talk about a design pattern, first of all you need to understand what the intent is. In command pattern, the intent is to encapsulate a request as an object, thereby letting you parameterize clients with different requests. You can queue or log requests and support undoable operations. Okay, enough of all this theory. Let's write some code and see how we can implement command pattern. Since the very first concept is, since we said commands is nothing but closures, let's start with an example that will illustrate this. Cement the theory with some practice. So I have a counter with a variable count initialized to 0, and I have an array of commands. I'm going to loop through 1 through 10, and I'm going to save a proc objects into the commands array. It's a very simple proc object. All it does is increment the value, the existing value of the count by 1. That's it. So what would happen if I print the value of the count here? What do you think will be the value when I call this? I expect that to be actually 10. Let's see what happens. Since you're not calling any objects, it will be 0. Okay, the value will be 0. And it is 0. Okay, delayed execution. We haven't executed that yet. All the proc objects are stored in the commands array, and we can decide when to execute it. Let me just execute the first command. It will execute once, so the value will be 0 and then 1. Let's print the value. See how the value was 0 and then it became 1. Let's illustrate this thing in detail. Let's me execute once more. I repeatedly call this thing one by one, and let's check the count. 0, 1, 2, and so on. So it has some kind of a memory. It knows what the previous value is. When we went through the concept of closure, we said one of the significant things about closure is the value established in one invocation remains available in the next. That's what happens here. It was 0 here, and then it was 1, and then it was 2 at the it was 0 first time, it became 1, second time it became 2, as you can see from here. And also then point number one was the blocks have the ability to access variables outside of its block. So here is a block right here, do end, this is a block. And this, see how it's accessing the value here, which is outside the block, is the outer method. So that's another very distinguishing feature of Clojure. So by using closures, we are able to come up with elegant solutions, and the language itself seems to have the command pattern that it does not require very structure heavy solution. Instead, we are just using the language features to implement the command pattern. Okay, let's see one more example of the command pattern in action. And one of the things we mentioned in the intent was being able to queue or log requests and support undoable operations. That's what I'll illustrate in this example. And there will be two methods. After the constructor, we will have it's kind of like execute and unexecute. Execute will just call the do proc object stored in the do variable, and undo will do the exact opposite. Let's just create a method. We're going to instantiate a command object and save it in the commands array. So how do we encapsulate a request as an object? We're going to use proc object to encapsulate a request. Our request will be nothing but a proc object like this. Do and undo. Do will be increment, undo will be decrementing that value. So undo is the next in the constructor. Let's print the count first and execute all the commands, do commands, and then we'll print the value of the count, and then we will undo all of the commands by calling the undo command method, and then we'll check it it really did undo. Let's call the undo command demo here. So let's execute this. As you can see, the initial value was 0, and then we incremented all the way to 10. And when we undid the values which were incremented by the do command, we went back to 0. So as you can see, the structure that we needed was very minimal. So command design pattern is built into the language by means of closures, and you can just add structure when you really need them. You don't need to have a receiver and have all. If you see the Ganga for design patterns, it's got a lot of structures, a lot of classes going back and forth. So it kind of gives you some kind of an idea of how to effectively use closures, proc objects, lambdas, and all this cool stuff in Ruby. So that's it for this screencast, and if you enjoyed it, please recommend me on working with Rails. Thank you.